Hello and welcome to Cisco Router Training 101. My name's Don Crawley. I'm from soundtraining.net. We're the Seattle, Washington-based publisher of learning resources and provider of accelerated training for IT professionals. This time we're going to talk about Cisco Router Access List. This is part one of a three-part series. In this video, we'll cover the fundamentals. So we'll be covering things like standard access control lists and how to apply them, and just some of the fundamentals of access control lists. It's based on Chapter 11 in my book, The Accidental Administrator, Cisco Router Step-by-Step Configuration Guide. The book is not required, but if you'd like to get a copy to follow along, it's available through the usual online resellers, including www.soundtraining.net/bookstore. Our software version is Cisco iOS version 15.1. The basic concepts that we're going to cover go way back in the iOS version, so even if you're using an older version, say even 11, most of what we're going to talk about will apply. There are some enhancements in more recent versions of the iOS, and I'll try to point those out as we go through the training. So as I mentioned, this is part one, and we're going to cover the fundamentals, including standard access control lists. In part two, I'll go over extended access lists, object groups, and named access lists. And in part three, we'll cover IPv6 access lists for you. So, as I said, this is part one. And here are the prerequisites for this lesson. You'll need unrestricted privilege mode access to a Cisco router. And very important that you have an understanding of IP addressing, including subnets, dotted decimal notation, and CIDR notation before you get into this. If you're not comfortable with that, then watch our video on IP addressing and get comfortable with it, and then come back to this video. Equipment software requirements: one Cisco router. The one I'm using is a Cisco Model 1941. You'll also need a computer for your management workstation connected to one interface on the router, a console cable, and terminal emulation software such as PuTTY, which is the one I'm using. You could also use TerraTerm, Secure CRT, or even HyperTerminal if you'd prefer. Here's your disclaimer. This video is provided solely as a courtesy to you, our viewer. There are no guarantees whatsoever. Do not attempt these procedures on a production router without first testing them for security and suitability in a lab environment. Performing these procedures may open your router to the public internet and subject your network to attack. So make sure you have current backups and take precautions including data encryption and additional access controls to protect sensitive data. As usual, and always good advice. So what exactly is an access control list? Well, it's really very simple. It's a sequential list of permit and deny conditions or statements that are known as access control entries. And you apply them to a router interface. Typically, you might apply it to a logging function or a VPN tunnel or something else, but it's a way of identifying a traffic flow. It's a way of saying, I want to recognize and either permit or deny traffic that originated in this subnet, this network, or this host. And with an extended list, you can do more than that, but it's still a way of identifying a traffic flow and permitting or denying it. Now, a couple of things to think about. First of all, the list is read in sequential order from top to bottom until a packet matches an entry. And once the packet matches an entry, then testing stops. So as soon as there's a match, nothing that comes after the match is read. Let's take a look at this video and you'll see what I mean. Take a look at the access list, and you'll notice that we have three statements denying access from particular networks. Now, I'm not going to get into the syntax right now. We'll do that in a minute. But right now, just know that this access list denies any packets from the 10 network, the 20 network, or the 30 network. You'll notice that the fourth line in the list permits packets from host 30.0.0.1, which is on the 30 subnet, or the 30 network, the one that is denied in the line right above it. Here's what's going to happen. A packet will come in. We've got an animation for you, so take a look at this. The packet comes in from 30.0.0.1. First it's permitted, again it's permitted, but now, because it matches the deny statement at 30.0.0.0, it never gets to the line that permits it. So the packet is dropped. Just like that. So it's very important to understand the ordering of lines in an access list. And we'll go over this again in a moment, but for right now, understand that it's important to go from most specific to most general. And the problem with the list that you're looking at right now is that it does the exact opposite. It goes from most general, where it denies an entire network, to most specific, where it tries to permit an individual node or host, but because it denies that network, it never gets to the line permitting the host, and the packet is dropped. Now, a couple more things that you need to understand about access control lists. There's an implicit deny any at the end of every access control list. So if a packet doesn't match any of the entries in the list, it is dropped. Now, here's the way to think about this. Anything that is not explicitly permitted is implicitly denied. So if you don't have a line in a list explicitly permitting a particular traffic flow, it's going to get dropped. Now, a lot of people will put a permit any statement at the end of the access list. And if that's what you want to do, if you want to permit all traffic other than that which you've explicitly denied, then that's great. Some people say, well, should you just always do that? And the answer is no, it just depends on what you want to do. But it's very important to remember that if a packet doesn't match any of the entries in the list, it is dropped. And when you're troubleshooting, one of the first things to do is to look at the access control list and see if maybe that's where the problem is. Next thing you need to know about access control lists is the list must be applied in order for it to have an effect. In other words, if you don't apply it to an interface, then it's just floating around out there, not doing anything, and it'll have no effect at all. We'll go over the syntax on that in a moment. Now, there are two types of IPv4 access control lists. First is the standard access control list, and they're numbered 1 through 99, or there's an expanded range that was supported starting with version 12.0.1 of 1300 through 1999. And I'll talk more about those numbers in a moment, but just know that if you use a number between 1 and 99 or 1300 and 1999, that tells the router that you're working with a standard access control list. And a standard access list acts only on the source IP address for filtering. It doesn't look at anything else, only where the packet came from. Now, the extended access control list that we're going to cover in the second part of this video series is numbered 100 through 199 or 2000 through 2699. And unlike a standard access control list, which acts only on the source IP address for filtering, an extended list can filter based on the source IP address, the destination IP address, protocol type, or port number, or any combination of those. So you have a lot more granularity with an extended list than you do with a standard list. Sometimes people say, well, should you just always use the extended list? And the answer again is no, it just depends on what you want to do. A lot of times a standard list is sufficient, and why make things more complicated? So if you can, use the standard. If you need it, use the extended. A couple more rules for access control lists. First of all, one list per type, per direction, per interface. And a lot of people get kind of confused on that. But here's the thing. You can have one standard list, that's the type, per direction, inbound or outbound, on, say, interface gigabit Ethernet 0/0. You could have another list of the same type in the same direction on another interface, but you can't have two lists of the same type in the same direction on the same interface. Now, the number of the list, we talked about that a moment ago, and here's the deal on the number of the list. The number identifies the type. It's the range, actually. So if it's within the range of 1 to 99 or 1300 through 1999, it's a standard list. And if it's within the range of 100 through 199 or 2000 through 2699, it's an extended list. And here's the deal on the numbering. Within the range, there's no significance to the number. There's no priority. It's merely a label that tells the router what type of list it is. So there's no difference between access list 10 and access list 25. They're both standard lists. One doesn't have any particular priority or significance over the other. And same thing with extended. There's no difference between, say, 110 and 2500. They're both extended lists. One has no significance over the other. Here's the syntax for a standard access control list, and you'll do this in global configuration mode. So your prompt will say config, and then you'll use the command access-list. You'll specify the number. In this case, I just used the traditional 1 through 99, but you could also do the expanded range if you wanted. Then a permit or deny statement, and that's exactly what the name implies. You're either going to permit traffic, you'll allow it, or deny it. You're going to block it. Then the source IP address. And the source IP address could be either a full classful network, it could be a subnet, or it could be an individual node. And then the wildcard bits. And the wildcard bits is really just another way of expressing the subnet mask. And what we do for the syntax on wildcard bits is we invert the actual mask. So, for example, to permit traffic from the 192.168.1.0/24 subnet, we'll use the statement access-list 10. This is just any number 1 through 99. Permit, because we want to allow that traffic. 192.168.1.0. That's the subnet ID, or actually that's a full classful network ID. And then the inverse mask. Now, if you think about it, A traditional 24-bit mask in dotted decimal notation would be 255.255.255.0. But when we're expressing it for the wildcard bits in an access control list, we use an inverse mask. So everywhere where there's a 255, we replace it with a 0, and everywhere where there's a 0, we replace it with a 255. So our inverse mask is 0.0.0.255. Now, I'll explain this in more detail in a moment, but we're also inverting the bits. So anywhere where there's a 1, we change it to a 0. Anywhere that there's a 0, we change it to the 1 in the mask. Now, let's do another example. If you want to deny traffic from the 100.25.0.0/16 network, you'd use the statement access-list 5, again, any number between 1 and 99, deny because we want to block it. 100.25.0.0, that's the network address, and then the inverse mask. Well, normally a 16-bit subnet mask would be expressed as 255.255.0.0. We simply flip it and express it as 0.0.255.255. Now let's talk a little bit more about the wildcard, or the inverse subnet mask. What it does is it identifies the matching bits in an IP address. So if we have, say, a /24, that means that we want to operate only on the first 24 bits of that address, and we don't care about the last 8. If we're dealing with a standard Class C, traditional Class C address, then we want to act on the first 24 bits. Wildcards are used in router access lists and some routing protocols, such as OSPF and EIGRP, and as I mentioned, it's simply an inverse of the corresponding subnet mask. Here's what it looks like in binary, and this is what you really need to understand if you want to really grasp the meaning of this. And if you're working on a CCNA, this is going to be very helpful. The inverse of the corresponding subnet mask means that the ones in the actual mask are inverted to zeros in the wildcard. An actual 24-bit mask, a /24, of 255.255.255.0 becomes 24 ones followed by 8 zeros, right, in binary? Well, a wildcard inverts it. They invert the ones, changing them to zeros, and that ends up with 24 zeros followed by 8 ones, and if you do the math, that equals 0.0.0.255. And that tells the router to match the first 24 bits. The last 8 could be anything. Here's another example. This time let's do a 23-bit mask. So the actual mask is a /23. In dotted decimal notation, it would look like this, 255.255.254.0. In binary, it's 23 ones followed by 9 zeros, as you can see in the example. The wildcard /23 is simply 23 zeros followed by 9 ones, or 0.0.1.255. And again, we match the first 23 bits. The last 9 could be anything. Let's do one more example. Here's a 27-bit mask. So the actual mask in dotted decimal is 255.255.255.224, or 27 ones followed by 5 zeros. So the wildcard is, what do you think? If you said 27 zeros followed by 5 ones, you're exactly right, or 0.0.0.31. Now, if you're not sure where that 31 came from, pause the video and do the math on the binary in the wildcard, and you'll see it. It matches the first 27 bits, and the last 5 can be anything. Now, here's a shortcut that you can use to figure out what the wildcard actually is, the inverse mask. You just subtract the actual mask from 255.255.255.255. Here's an example. If we have a 24-bit mask, the actual mask would be 255.255.255.0. When we subtract it from that string of 255s, we end up with 0.0.0.255. Here's another one. 255.255.254.0. Subtract it from that string of 255s, and you end up with 0.0.1.255. And finally, here's the last example, the 27-bit mask that we showed you in the previous slide. This time, our actual mask is 255.255.255.224. Subtract it from the string of 255s, and you end up with 0.0.0.31. So it's really pretty simple if you want to just do a quick shortcut. This doesn't show you the theory behind it, but sometimes you're in a hurry to get a configuration done. I get that, and so this is a quick way to knock it out and make it work. Now, there's really good news because on newer versions of the iOS, the Cisco iOS now supports the use of CIDR notation instead of the inverse subnet mask. So now you can, and it looks like this started with version 15 of the iOS. I haven't been able to find documentation that says exactly when Cisco turned it on, but I have some routers running version 12. They don't support it. Another router running version 15, and it does. So, however, regardless, you can check it out and see. I'll show you how to do this when we do the demo in a moment. You can, on a router that supports it, use a /24 instead of 0.0.0.255 or /27 instead of 0.0.0.31. So it makes it much simpler. And Cisco's been trying to improve the usability of the iOS, and this is a good example of that. Now, here's the syntax of an IP standard access control list. Here you can see we have 3 deny statements, access list 10, deny, and then we have 3 different networks. And I followed that with access list 10, permit any, because if I didn't do that, the fact that I have 3 deny statements in there, actually all I'd need is 1, because that would then deny all traffic without a permit any at the end. Now, as I mentioned earlier, the order of entries is very important. Here's an example of going from most general to most specific and how it won't work. Notice that this particular access list 10, denies the 192.168.0.0 subnet or network. And then there's a permit statement permitting a particular host that is on the denied network. Well, it's never going to get to the permit statement because as soon as a packet from host 192.168.0.1 hits the list, it'll be denied at that first line. So you have to invert it and do it this way. So we do access list 10 permit host 192.168.0.1. We put the most specific statements first, followed by the most general. And that one will work. On newer versions of the iOS, this again is from version 15, the router will actually complain if you try to go from most general to most specific. It'll throw off an error like this saying that the access rule can't be configured at a higher sequence number as it's part of the existing rule at sequence number 20. Now, you may not see the sequence numbers, but they're there, and I'll show you that when we do the demo in a moment. You can see the access lists that are available on your router with the command in global configuration mode, access-list space question mark. If you have, say, an old 2501 router that's got, say, the enterprise feature set on it, that router is going to support not only TCP/IP, it's going to support IPX/SPX, DECnet, AppleTalk, and several other older legacy protocols, and you can see those access lists are supported on that particular router. Newer ones, pretty much limited to IP, IPv6, and a couple of other things somewhat related. Now, once you've created an access list, it does no good until you apply it to an interface. And in order to do that, we go into interface configuration mode. So first we go into configuration mode, global configuration mode. Then we go to interface, in this case G0/0. Then once we're at that interface, we use the command IP access-group, the number of the list, and then in or out. And this is important. In or out is from the perspective of the router. A lot of people get confused about this, but just remember that if it's going away from the router, then it's outbound, and if it's coming toward the router, it's inbound. Again, in or out is from the perspective of the router. I'll show you that in a slide in a moment. So let's work through this exercise together, and then I'll do some demonstrations on a live router for you. Our objective here is to deny members of the sales LAN access to the R&D LAN, but to allow access to the internet and managers, and we want to allow all other networks full access to all other networks. In other words, all we want to do is block sales from getting to R&D. Now, this is kind of a goofy network that would allow the internet into R&D, but they have their reasons, I'm sure. So, again, what we want to do is block sales from getting to R&D. So let's see how we might do this. First of all, remember that we're dealing with standard access control lists, and a standard access control list filters based on what? Remember, it's only the source IP address. So all we can look at is where's the traffic coming from. So that would say that we need to do something with the sales LAN, right? So let's start by creating an access control list that blocks access from the sales LAN. So our access list 10, and I just picked a random number between 1 and 99, access list 10 deny, then 10.3.0.0 with an inverse mask of 0.0.255.255 because that's a /16. And if you're kind of confused on that, go back and watch the previous part of this video until you feel comfortable with it. Now, is that going to do the trick? Well, no, because we're going to deny everything else. And remember, part of the objective is to allow all other access. So we have to add an access list 10 permit any statement in order to allow all other traffic. Now, does that do it? Well, no, because we haven't applied it to an interface yet. So take a look at the router. It's got 4 interfaces, and on which one do we want to apply the access control list? Only one's going to do the job. Which one do you think it is? Well, if you said interface gigabit Ethernet 0/0, you'd be right. So we'll use the command IP access group 10 to apply it. But we still have to figure out whether it's going to be in or out. And what do you think? Is it in or out? Remember, it's from the perspective of the router. So traffic going away from the router would be outbound. Traffic coming toward the router would be inbound. We're going to put it on interface gigabit Ethernet 0/0. That's the one connected to R&D. So traffic flowing through that interface toward the R&D subnet would be outbound. So the command is IP access-group 10 out. I'll let that sink in for just a moment. All right, well, let's do a demo here and show you how to set up an access control list. So the first thing we need to do is find out about the state of the router. Let's do a show IP interface brief command just to find out its IP address. And there you can see the outside address is 192.168.1.6. Let's do a ping to it from the PC. So let me open up PowerShell and let's try that ping. So we'll ping 192.168.1.6 from the PC and see if we get a response. So there, we do get a response. What we want to do is just block it. So let's go back to the router interface. Take a look and see if there's any access list configured. So we'll do the command show access list. Nothing there. So we'll go into global configuration mode, configure terminal, abbreviating it, conf space T. Let's do the command access -list space question mark, just so you can see the access lists that are available on this router. And pretty much what you'd expect. Let's do access list 10, deny 192.168.1.0. And then our inverse mask, which is 0.0.0.255. And is that going to do the trick? Well, we still need to permit other traffic. So let's do access-list 10 permit any. Now, I could, by the way, have just as easily done the statement access-list 10 deny 192.168.1.0 and put a slash value on it. Let me show you what I mean. If I put a question mark there, you can see that it now supports a slash value, CIDR notation for the wildcard bits. But that's new, and older routers, even not very old routers, don't support that. So just be aware of that. We'll go ahead and delete that line. And let's do the command do show access list so you can see the list there in the router. Notice there that you can see the sequence numbers, 10 and 20. And every time I add a new line to the list, it's going to increment it by 10. We don't need to add any more. And in fact, if we go try the ping right now, let's see what happens. So we'll go back to our PowerShell, use the up arrow to repeat the command, and what's that? It's working. Why is it working? I thought we just created an access list denying it. Well, if you said the reason it's working, Don, is because you didn't apply it to an interface, you're absolutely right. So let's go do that. So if I look at my output from show IP interface brief up above, I can see that I want to configure interface gigabit Ethernet 0/1. So let's do that. Interface G 0/1. Then I'm going to use the command IP access group 10 to match the number of the list, and then in or out. What do you think? Well, the answer's in because it's coming toward the router. Right now, I'm trying to ping from outside coming in, so I want to use inbound. I want to block inbound traffic. So we'll apply that, and now let's go back to PowerShell and try the ping again. Let's see what happens. And look at that, destination net unreachable. So success. I reset the terminal to clean things up, but if you want to remove the access list, then you have to just use the no version of the command. So let's go back to configuration mode, and we'll use the command no access list 10, and that removes the entire list. If I use the command do show access list, you can see that it no longer exists. Now, if I take a look at the interface, you can see that the access group is still on the interface. Let's do that. Let's do show run. Then I'm going to use a pipe filter and do section interface. So we can just look at the interface section. And right there under interface gigabit Ethernet 0/1, you can see that the access group is still applied to the interface. It's just not having any effect right now because we removed the access list. And to show you what I mean, let's go back and try that ping again. And this time it works. Now, it is possible to modify access control lists without deleting the entire one if you're working with named access lists, which we'll cover in our next video in part 2 of this 3-part series on access lists. So again, in Cisco Router Access List Part 2, we'll be covering named access lists. In addition, we'll also go over extended access lists and object groups. If you'd like more information, we have it available online at our website at www.soundtraining.net. I blog at soundtraining.net/blog. You can subscribe to our newsletter. Also like us on Facebook, follow us on Twitter, and if you'd like to join us on Google+, we're there as well. If you'd like more videos, we've got a ton of them available at our video channel at www.soundtraining.net/videos. And the companion book is The Accidental Administrator Cisco Router Step-by-Step Configuration Guide. It's available through the usual online resellers and at www.soundtraining.net/bookstore. Well, I hope it's been helpful. For soundtraining.net, I'm Don Crawley. I'll see you next time.